On the 27th of December 2024, a spacecraft called Juno swung past a small moon of Jupiter and measured something no instrument had ever recorded before. A single volcanic hotspot in the moon's southern hemisphere, glowing in the infrared across an area larger than Lake Superior. 65,000 square kilometres of molten ground. Not a vent, not a crater glowing at the bottom. A region of open, liquid rock so vast you could lose entire countries inside it, radiating in the dark like a coal pulled fresh from a fire, pouring out energy at a rate somewhere between 140 and 260 trillion watts. More power from one eruption than every power plant on Earth combined, several times over. Take every reactor, every dam, every coal and gas station humming on our entire planet, add them all together, and this one wound in the ground was outshining the lot of them by a factor of 6. It was the most powerful volcanic event ever seen anywhere in the solar system, and here is the part that should stop you. It was not a freak. It was not a once-in-a-century catastrophe that the spacecraft happened to catch. On this moon, that is just a bad day. A particularly loud entry in a diary that has been writing itself in fire for billions of years. We have a strange blind spot when it comes to the worlds of Jupiter. We talk endlessly about Europa and its hidden ocean. We make documentaries about Ganymede being bigger than Mercury, about Callisto and where humans might one day land. We are drawn, always, to the worlds that promise us something. Water, shelter, the faint possibility of life. But the most extreme, most violent, most genuinely alien of the four, the one that is on fire right now as you watch this, almost nobody talks about. This is Io, a moon the size of our own, turned inside out by the planet it orbits, repaved by lava faster than craters can form, and wired directly into Jupiter by a river of electricity carrying millions of amps. It is the most volcanically active body in the solar system by a margin that isn't close. It is not the runner-up to anything, and the reasons it burns are the reasons it should not be possible at all. Tonight we are going to take the moon everyone skips and look at it properly. What it is, why it erupts, what it does to Jupiter, why nothing alive could ever stand on it, and how a young engineer staring at a navigation photo in 1979 became the first human being in history to see a volcano erupting on another world. Start with the size of it, because the size is the first surprise. Io is the innermost of Jupiter's 4 great moons, the ones Galileo found in 1610. It is the third largest of them, and it is just slightly bigger than our own moon, 3,643 kilometres across. Hold that comparison in your mind, because everything strange about Io grows out of it. This is not some exotic giant. This is a world almost exactly the dimensions of the pale, familiar disk you have looked up at your whole life. By every rule we understood for most of the 20th century, a body that size, this far from the sun, should be a frozen, cratered rock. Cold, still, dead. A second moon, hanging in the dark beside a giant. Our own moon is exactly that. It is almost the same size as Io. It is covered in craters billions of years old because nothing has happened on its surface to erase them. Every scar it ever took is still there, layered one on top of another, a face that has not changed in any way that matters since before there were oceans on Earth. It cooled off not long after it formed and has been a tombstone ever since. And this is the ordinary fate of small worlds. They lose their heat quickly. They have a lot of surface compared to their volume and the warmth of their formation, and the slow trickle of heat from radioactive elements buried inside them leaks away into space and never comes back. Picture a stone pulled from a campfire and set on a cold night table. For an hour it ticks and cools. By morning it is just a stone. That is the destiny of almost every moon and minor planet in the solar system. Geologically, they die young, and they stay dead for the rest of time. Io did not get the memo. Io is the most volcanically active object in the entire solar system. Not one of the most, and not by a little. There are more than 150 active volcanoes confirmed on its surface, and depending on how you count the hotspots, the real number may be closer to 400. 400? On a world the width of our moon. Lava fountains rise kilometres into the sky, curtains of glowing rock thrown up and falling back in slow, alien arcs, because the gravity is weak and there is almost no air to slow them. Lakes of molten rock sit open to space, their surfaces crusting over and breaking apart. Plumes of gas and dust erupt 300 kilometres upward, high enough that they punch clean out of the moon's thin grip and rain back down across the landscape like a snow made of frost and ash. And there are mountains on Io taller than Everest that have nothing to do with volcanoes at all. They are pieces of crust shoved bodily upward by the sheer pressure of a surface being constantly recycled from below, slabs of broken ground tilted at impossible angles like ice flows in a frozen river, except the river is the moon itself, a world the size of our dead grey moon, and it is the single most geologically alive place we know of. Sit with the contradiction for a second, because it is the whole story. Same size, same era of birth, same cold neighbourhood of the solar system. One is a tomb, the other is a furnace that has never once gone out. Something is pouring heat into Io on a scale that, by all the ordinary rules, should be flatly impossible. To understand Io, you have to understand where that heat comes from, because it is not coming from inside Io at all. It is coming from Jupiter. Io orbits Jupiter close. Very close. It circles the largest planet in the solar system in just 42 hours. A whole year for Io, packed into less than 2 of our days, skimming through the most intense gravity field of any world out here. And Jupiter's gravity does not just hold Io in place, the way the sun holds the Earth on its long calm leash. It needs it. The mechanism is called tidal heating, and it is the secret fire of the outer solar system. It is one of those ideas that sounds gentle until you do the arithmetic, and then it becomes terrifying. Here is how it works. If Io were alone, orbiting Jupiter on a perfect circle, it would settle into a steady state and slowly go cold like everything else. A perfect circle is a calm thing. The pull would be the same at every point in the orbit, the moon would relax into it, and within a geological eye blink it would freeze solid. But Io is not alone. It is locked into a precise gravitational rhythm with the 2 moons just outside it, Europa and Ganymede. For every 4 laps Io makes around Jupiter, Europa makes 2 and Ganymede makes 1. 4, 2, 1. This is called the Laplace resonance, and it is one of the most elegant arrangements in the solar system. Because the 3 moons keep lining up in the same pattern, over and over in the same places, they tug on each other in the same direction over and over, like pushing a child on a swing at exactly the right moment, every single time. Each small push lands in step with the last. Nothing is wasted. The motion builds. Those repeated, perfectly timed tugs stop Io's orbit from ever becoming a perfect circle. They keep it very slightly stretched, very slightly egg-shaped, and they will not let it relax. And a stretched orbit means that as Io swings closer to Jupiter and then further away, the strength of Jupiter's gravity on it rises and falls on every single lap. The planet pulls harder on the near side of the moon than the far side, and as that difference grows and shrinks, the entire solid body of Io is squeezed and released, flexed like a ball of putty worked endlessly in a hand that never tires and never lets go. The numbers are difficult to hold in your head, so let me give you something to picture. The solid surface of Io rises and falls by as much as 100 meters on every orbit. Not the tide of an ocean, the ground itself, the whole moon breathing. A swell, moving through solid rock, lifting the land beneath your feet by the height of a 30-story building, and then setting it back down again, twice every Io day, every day, forever, with no shoreline, no calm, no end. If you could stand on Io and somehow survive the standing, you would not feel the world move beneath you any more than you feel the Earth turning. But it would be moving all the same, the entire crust heaving up and sinking back, the rock kneaded so hard and so ceaselessly that it cannot help but grow hot. Because that is what flexing does. Bend a paperclip back and forth, and the metal at the joint grows warm in your fingers. Bend it enough and it is too hot to touch right before it snaps. Io is that joint on the scale of a world, bent without rest for billions of years. All that flexing generates friction, all that friction generates heat, and the heat has nowhere to go but up. Into the crust, into the magma chambers, out through the volcanoes and into the dark. Io radiates more internal heat than it has any right to produce. Far more than the leftover warmth of its formation could explain. Far more than radioactive decay could ever supply. It is being heated from the outside by being bent by a planet roughly 300,000 kilometres away. Jupiter is in effect plugging Io into a wall socket made of gravity, and Io is glowing because of it. When Juno mapped the moon in 2024, the picture that came back matched all of this perfectly, and then added a detail that made it even stranger. Io's interior is not a simple molten ball with a solid skin, the way you might imagine. It is riddled with magma chambers, pockets and veins and reservoirs of liquid rock threaded all through the upper layers, a sponge soaked in fire. The researchers described it almost exactly that way, a spongy world consumed by molten rock. The heat is not made in one furnace at the core and pushed outward. It is being made everywhere, all at once, all the time, through the entire body of the moon, and the surface is simply the place where it finally finds a way out. Here is one of the strangest things about Io, and one of the most telling. It is the kind of fact that, once you really understand it, changes how you see the whole moon. It has no impact craters. Think about how unusual that is. Every other solid surface in the solar system is scarred. The moon, Mercury, Mars, Callisto, the asteroids, all of them carry the record of 4 billion years of bombardment. Crater on top of crater on top of crater, going back almost to the beginning of everything. Impacts are universal. Space is full of debris, and over the long ages everything out here gets hit and the marks stay. A crater on an airless world is close to permanent. It is a wound that never heals. Read the surface of the moon, and you are reading a logbook 4 billion years deep. Io gets hit too, by the same drifting wreckage as everyone else, by the same wandering rocks. It is not somehow protected from the bombardment, and yet you can photograph Io from pole to pole, search every square kilometre of it, and not find a single confirmed impact crater, anywhere. The reason is simple and astonishing. Io repaves itself faster than the craters can accumulate. The volcanoes resurface the entire moon, burying old ground under fresh lava and sulfur and ash on a timescale of perhaps 1 million years or less. On the scale of the solar system, 1 million years is the blink of an eye. It is nothing. So every impact scar Io has ever received, every crater punched into it across the whole of its history, has already been paved over, drowned in new rock, erased. The surface you're looking at, whatever image of Io you have ever seen, is geologically brand new, always. It is younger than our own species. Io is the only world we know of that has in effect no past written on its face. It does not keep a record. It erases its own history continuously and starts again. And what a face it is, this surface that is forever being repainted. The colours are unlike anywhere else in the solar system. Yellows, oranges, reds, white and black, vivid and lurid, the palette of sulphur and its compounds laid down fresh by the eruptions and baked by the heat. People who first saw the Voyager images said it looked like a pizza, and the comparison stuck, and you can see why. But it badly undersells how alien the place really is, how nothing about it belongs to any landscape a human eye was built to read. There are lakes of molten silicate rock kilometres across, with crusts that form and crack and founder and sink, exactly the way ice breaks up on a thawing pond in spring, except the pond is liquid rock at temperatures that would vaporize you, and the breaking crust is glowing. There are fields where the ground is warm to a depth you cannot imagine. There are mountains higher than anything on Earth, leaning at angles that should not stand, shoved up by a crust under so much pressure from below that it simply buckles and heaves. It is beautiful in the way that the inside of a furnace is beautiful, or the heart of a forge. A terrible radiant beauty with nothing soft in it, and it is utterly, lethally hostile, though as we will see, the lava is not even the thing most likely to kill you. Now we come to the part that almost no documentary mentions, and it is the part that makes Io genuinely unique in the solar system. Not just unusual, but one of a kind. Io is not simply a moon orbiting Jupiter, it is electrically connected to it. The two of them are joined physically by an invisible thread right now. Start with the atmosphere, because even that is strange. Io has one, barely. A whisper of gas, mostly sulfur dioxide, breathed out by the volcanoes and freezing onto the cold surface as a pale frost. It is so thin it is almost a vacuum. You would not call it air so much as the memory of air. and it does something no other atmosphere in the solar system does. When Io passes into Jupiter's shadow and the sunlight cuts off, the temperature plunges, and much of that thin atmosphere literally freezes and falls out of the sky onto the ground. The air collapses, it snows itself flat. Then, when Io swings back into the light, the frost sublimates, the gas lifts off the surface again, and the atmosphere reinflates. The moon breathes in and out with the passing of its own day, exhaling into shadow, inhaling into light, over and over on a 4-day rhythm. But the volcanoes do not just feed Io's own thin air, they feed Jupiter itself. Every second, Io throws roughly a ton of material, sulfur and oxygen stripped of their electrons, turned into electrically charged particles, up and out into space, away from the moon entirely. A ton every second, ceaselessly for as long as anyone has been watching. Jupiter's enormous magnetic field grabs that escaping material and whips it around, smearing it into a vast, glowing, donut-shaped ring of plasma that traces Io's entire orbit all the way around the giant planet. It is called the Io plasma torus, and it is one of the largest structures in the solar system that you have almost certainly never heard of. A luminous ring millions of kilometres around, fed by one small fountain. And Io is that fountain. Io fills it. Since the Voyager flybys in 1979, we have known that this one small moon, this body the size of our own moon, is the single greatest source of material in the whole of Jupiter's magnetosphere, a region of space larger than the Sun. Let that land properly. A moon the size of ours is supplying the raw material for a magnetic empire millions of kilometres across, an invisible kingdom that dwarfs every planet in the solar system. And then there is the flux tube. This is the detail that should be famous, and somehow isn't. Because Io is a conductor, a body that carries electrical charge, and it is moving fast through Jupiter's titanic magnetic field. It does what any conductor moving through a magnetic field does. It generates a current, but not a small one. A colossal electric current flowing along the magnetic field lines that connect Io directly to Jupiter's north and south poles, threading the gap between moon and planet. That current runs to millions of amperes, and where those field lines slam down into Jupiter's upper atmosphere, they light it up. They kindle a bright, permanent glowing spot in Jupiter's aurora, a spot that moves as Io moves, that tracks the moon around its orbit. The footprint of a moon, stamped in living light onto the face of a planet. There is a cable of electricity, invisible and continuous and impossibly large, running between Io and Jupiter as you sit here. It has never switched off. Let that sit for a moment. We are used to thinking of moons as passengers, dead rocks dragged around by their planets, going wherever they are pulled, contributing nothing. Io is not a passenger. Io is an active component of Jupiter. It powers part of the planet's radiation environment. It lights part of its aurora. It carries a current that would vaporize any human-made wire in an instant and feed a structure broader than the Sun. It does not merely orbit Jupiter. It is plumbed into it, wired into it, part of the machinery. It is less a moon than an organ, a beating, burning organ of the largest planet we know. So could you ever stand on it? Could a future astronaut in some armoured suit plant their boots on that glowing ground and watch a lava fountain on Io the way explorers on Earth once stood at the rim of Kilauea and watched the planet bleed light? No. And it is worth being precise about why, because the answer is not the one you would expect. The lava is the least of it. Io orbits deep inside Jupiter's radiation belts, the inner edge of the most hostile particle environment in the entire solar system. Jupiter's magnetic field, the same field that whips Io's exhaust into a glowing ring, also traps electrons and ions and accelerates them to enormous, savage speeds, and it holds them in great invisible belts around the planet. And Io sits right in the teeth of it. There is no shelter where Io is. The radiation raining down on its surface is measured in thousands of rem per day. Let me put that number in human terms because on its own it means nothing. A dose of around 600 rem, received all at once, kills about half the people who receive it. 600 rem is a death sentence with a coin flip's mercy. Io delivers many times that, every day, without pause, forever. An unshielded human standing on Io would not be killed by the volcanoes. They would not live long enough for the heat to matter. They would be killed by the invisible sleet of charged particles pouring down out of an empty-looking sky, long before the fire ever became the problem. The most dangerous thing on the most volcanic world in the solar system is the part you cannot see. This is the cruel symmetry of the Jupiter system, and we have traced it before on this channel. The further out you go, the safer it gets. Callisto, far out at the edge, is bathed in only a tiny fraction of this fury, and might one day host a human outpost. A real place where people could live behind reasonable shielding. Europa, closer in, with its tantalizing ocean, is a death trap behind a wall of radiation that would defeat almost any visitor. And Io, the innermost of them all, is the worst, the most beautiful and the most lethal ground in the solar system at the very same time. The two qualities are not a coincidence. They are the same fact wearing two faces. The very thing that makes Io spectacular, its closeness to Jupiter, is the exact thing that makes it unreachable. You cannot get near the fire without standing in the radiation that the fire itself helps to create. To approach the wonder is to enter the kill zone. So we will not be landing on Io. Not in any future we can presently imagine. We will only ever visit it the way we always have, with machines. Robots falling past at speed, grabbing what data they can in the brief window before Jupiter's belts begin to fry their electronics, and then fleeing back out to the relative safety of distance. Even Juno, a spacecraft built like an armoured vault, its delicate brain wrapped in a shielded titanium box specifically to survive this place, only dips in for flybys before retreating. Nothing we have built can linger there. Io is a place we are allowed to look at, and never to touch. For most of human history, nobody knew any of this. None of it. Io was a point of light, one of the 4 faint sparks that Galileo watched moving around Jupiter in 1610, night after night, in the observation that helped crack the whole sky open. 4 little dots, shifting their positions from one evening to the next, plainly circling the giant and not the Earth. Proof, held in a homemade telescope, that we were not the centre of everything. And for 3.5 centuries after that revelation, Io stayed exactly what it had been, a point of light, a dot, a name in a list of moons. Nobody imagined fire. Why would they? It was a speck beside a planet, unimaginably far away and cold. Then, in March of 1979, the Voyager 1 spacecraft flew through the Jupiter system, and everything changed in a single afternoon. A few days after the closest approach, an engineer named Linda Morabito was doing routine work, the unglamorous, essential work that keeps a spacecraft on course. Her job was navigation. She used the background stars and the precise positions of the moons to work out exactly where Voyager was in the vast dark, the way a sailor once fixed a ship by the constellations. She pulled up an overexposed image of Io, deliberately brightened far past the moon itself to bring out the faint stars near its edge so she could measure against them. And in that washed-out frame, she noticed something that should not have been there. A strange fan-shaped cloud rising off the limb of the moon, off the very edge of its disk, reaching more than 300 kilometres up into the black. Her first thought, the sensible thought, was that it must be another moon sitting in the background behind Io, catching the light. It wasn't. She checked. There was nothing there, nothing in any catalogue, nothing that could possibly account for it. And slowly, as she and others worked through what the image was actually showing, the truth came clear, and it was staggering. What she was looking at was a plume, an enormous volcanic eruption, caught in the very act, hurling material hundreds of kilometres up off the surface of a moon of Jupiter, frozen in a single photograph. It was the first time in the whole of history that any human being had ever seen an active volcano on a world other than Earth. Pause on that. Up to that exact moment, volcanism was something we quietly assumed belonged to our own planet, and maybe, long ago, to a younger Mars. It was an Earth thing. The idea that a small, frozen-looking moon out at Jupiter could be erupting right now, this minute, throwing fountains of matter into space, that was on no one's list of expectations, and here is the part that gives the whole story the shape of something almost designed. Just days before the flyby, a scientific paper had been published predicting exactly this, that tidal heating from Jupiter might keep Io's interior molten and volcanic. The prediction was barely off the press, and then the proof came back from the spacecraft in a navigation photo, almost in the same breath. The idea and the evidence arrived together days apart, as if the universe had set up the answer right before asking the question. In one navigation photograph, a working image, not even meant to be looked at this way, a moon went from a dot in a list to the most volcanically active world we know. Everything in this video, every fact we have walked through tonight, flows downstream from that single image and the engineer who looked closely enough to trust her own eyes. Since Voyager, we have watched Io erupt for more than 4 decades, through the Galileo orbiter circling Jupiter in the 1990s, through the patient eyes of ground telescopes, and now through Juno. And the longer we watch, the more we come to realise that Io's violence is not the chaos it first appears to be. It has structure. It is not random. Underneath all that fire, there is a rhythm. The clearest example is Loki Patera, the largest volcanic feature on Io, a single lava lake about 200 kilometres across, wide enough to swallow a small country whole. Loki is not some quiet pool. It is the brightest, most powerful volcanic source on the entire moon, and it does not just sit there pouring out heat at a steady rate. It brightens and dims on a cycle of roughly 500 days, flaring up and then quieting down, flaring and quieting, with a regularity you could very nearly mark on a calendar. Astronomers have tracked this slow heartbeat for years, watching the Great Lake swell with light and then settle, again and again. And recent work has tied that rhythm directly back to Io's orbit itself, back to the same tidal flexing that powers absolutely everything we have talked about, gently modulating the Great Lake as the moon's distance from Jupiter shifts across its cycle. The lake breathes with the orbit, the fire keeps time with the gravity, and the Juno data from 2024 hinted at something stranger still. It suggested that eruptions on opposite sides of Io may be synchronized, flaring up together, in step, across the whole face of the moon at once, as if the magma chambers buried beneath the surface are not separate at all, but connected into a single vast plumbing system that responds to Jupiter's pull as one body. Picture that for a moment. Not scattered volcanoes going off at random, but a whole moon's worth of fire possibly beating in time, the entire molten interior surging in unison to a rhythm set by a planet hundreds of thousands of kilometers away. This is the thing that lifts Io above being merely a spectacle, merely the colourful one. It is a natural laboratory we could never build and can never reach, a world where we get to watch tidal heating, the very same process that keeps Europa's hidden ocean liquid and might be keeping the tiny moon Enceladus alive, running at full, visible, catastrophic volume, with the lid off. Everywhere else, that process is shy. It hides under kilometres of ice. We infer it, we model it, we argue about it. On Io, it is naked. Every eruption is a measurement we did not have to set up. Every flare of Loki is data about how heat moves through the bodies of worlds. The fire is not just burning, it is telling us, in plain sight, how the entire outer solar system stays warm. So let us put Io back where it belongs, because the picture we were handed, the pizza moon, the colourful one, the body you mention politely after the interesting moons are done, is badly, comprehensively wrong. Io is the most volcanically active world in the solar system, and not by a small margin, but by a margin that isn't close. It is heated not from within but from without, squeezed molten by the gravity of the planet it orbits, flexed by 100 meters twice a day for the age of the solar system. It resurfaces itself so fast, so relentlessly, that it has erased its own history entirely and carries no craters at all, a world with a face but no memory. It feeds a ring of plasma millions of kilometers across, fountaining a ton of itself into space every second. It carries a current of millions of amps to Jupiter's poles, and lights a permanent moving spot in another planet's aurora, a moon writing on a giant in light. It is sheathed in radiation that would kill a human in a single day, and it gave us, in one overexposed photograph in 1979, the first volcano ever seen anywhere beyond Earth. Lay those facts side by side and the afterthought framing falls apart in your hands. There is a pattern here that we keep running into on this channel, and it is worth naming directly. The famous worlds, Europa with its buried ocean, Ganymede, the giant, larger than a planet, get the attention because of what they might be hiding. We love a secret. We love the locked room. Io hides nothing. It is the most honest world in the entire Jupiter system. Everything it is doing on the outside, in the open, in fire, all the time, where anyone with the right instrument can watch. And precisely because it is not mysterious, because it does not dangle the possibility of life, or a quiet place to land, or an ocean under the ice, we walk straight past it, on our way to the worlds that flirt with us. But think about what we are actually choosing when we do that. Doing something right now is far rarer than might be hiding something. Most of the solar system is dead and quiet, frozen, cratered, finished, the campfire stone gone cold 1 billion years ago. Io is neither dead nor quiet. It is the closest thing we have ever found to watching a world being born and destroyed in the very same instant, over and over, on an endless loop, with no sign of an ending, and no possibility of one as long as Jupiter holds it close. We skip the one world that is unmistakably violently alive. The eruption Juno measured in December 2024 has, in all likelihood, already been buried, paved over by the next one, and the one after that, and 100 more besides. By the time you watch this, the surface of Io has changed. The exact ground that was glowing larger than Lake Superior is gone, drowned under fresh rock, just another forgotten page in a logbook the moon refuses to keep. New lava has covered ground that was molten a year ago. The plasma torus has been refilled 100 million times over, the fountain never once running dry. The current to Jupiter has never, for a single second, switched off. Everything we have described tonight is not history. It is happening now as you breathe 600 million kilometres away. We will never stand there. The radiation alone forbids it, and the radiation, remember, is only the most obvious of the reasons. Io is a place built for machines and for distance, to be watched from a fast-moving spacecraft hardened against the storm, or from a telescope on a quiet, dark mountain back home, but never approached, never walked upon, never touched by a living hand. It is, in the most literal and permanent sense of the word, untouchable. A wonder behind glass that we did not make and cannot lift. And yet it may be the single most useful world in the whole Jupiter system, precisely because it holds nothing back from us. Every other world out there makes us guess, buries its secrets, forces us to model and infer and wait for the mission that might one day drill through the ice. Io simply shows us. It shows us tidal heating turned all the way up to its violent maximum. The same gentle, patient process that dialed far down keeps oceans liquid beneath the frozen shells of moons that might just harbour life. To understand Io is to understand the engine of the entire outer solar system running out loud and in the open, where we can finally see it work. So the next time someone lists the moons of Jupiter and saves Io for last, as the colourful one, the pizza, the afterthought, the one you mention when the interesting moons are done, remember what it actually is: the most violent place in the solar system, a moon the size of our own, turned inside out by a giant, wired into a planet by a river of electricity, and fire right now as you breathe and as you will be long after this video ends. Nobody talks about it. They should. If you would like to keep exploring the real science of the worlds we're only beginning to understand, consider subscribing. There is far more fire out there worth a closer look.